We're going to look at lots of little things about vectors. So we're going to start off with a polygon made of vectors. So I've got here our irregular polygon, but we'd notice that if we added the vector AB plus the vector BC plus the vector CD plus the vector DE plus the vector EA, we end up back to where we ended up, so that would be the zero vector. And that doesn't matter what polygon. If you end up back where you started, then you're going to have a zero vector. So the second thing we're going to look at is parallel vectors. Well, it's really easy to see that if I had the same vector in a different spot, that's going to be parallel. We don't even call it a different spot because a vector doesn't have a location, so those are the same vectors. But I could also see that if I multiplied that by, say, 2, I get a longer vector, but it's still parallel. Well, even if I multiply it by a negative number, it's parallel. So any parallel vector is going to be a scalar multiplication of your original vector. So if A and B are parallel, then some scalar times B. And in fact, this is a two-way. If this is true, then that's true. So it's not. This is a one-way statement. So I could change that if to and only if. All right. Next little thing that we're going to look at, a position vector. So if I've got a position A, let's say 2, 3, I can create a position vector by taking the vector from the origin to that point. So the position vector of A, or OA, would equal, in this case, well, I've gone across 2 and up 3. So in this way, positions can be turned into vectors. And the last little thing I want to look at, linear combinations of non-parallel vectors. It sounds a little more complicated. Okay, so if A and B are not parallel, then if I multiply A by anything, B by anything, and I find that it's equal to anything times A plus anything times B, then that implies that the 2 bits of A and the 2 bits of B, the multiplications, the scalars, have to be the same. And I think this is most easily sort of visualized. If I've got an A vector going in this direction, I've got a B vector going in this way, and when I've got some scalar multiplication, I've got some amount along this way, some amount along this way, so some amount along that way, some scalar of A and B, and I've got to my point. All this is really saying is if those are not parallel, then there is only one way of getting to this. You've always got to have this amount of A and always this amount of B. You can't have different amounts of A and B and still get to the same point.